Hey y'all, welcome back. Let's take a look at this homework. So these first couple of problems, we're just trying to find the missing, looks like the missing side length on each one of these. So what we'll do is we'll set up an equation that involves the correct trig ratio, and we'll definitely use a calculator to find this. But let's go ahead and show you how to set that up with 1A. We're looking for, let's see, the angle in question here, so our reference angle is going to be right here. And if that's our reference angle, 5.1 will be our opposite side, and x is our hypotenuse. So the trig function that we want to use here that deals with opposite and hypotenuse is sine. So sine of 36, I might have to make that text a little smaller to make this fit, equals opposite over hypotenuse, so that'd be 5.1 over x, and so we need to solve for x. Now I'm going to just kind of talk through how to isolate x here, although I'll kind of do it all in one step, just really to save a little bit of room here. Let me make this a tiny bit smaller, so we have a little bit more room to work here. Okay, so what was that 16 point? Okay, so this is our setup, and to solve it, we're trying to isolate x. So basically the two steps you have to do to isolate x is first, multiply x on both sides, and what that does is effectively makes x the coefficient of that trig function, so like x sine 36 equals 5.1, and then you're going to divide by sine 36. So if you do those two things, you'll end up with x equals 5.1 divided by sine of 36. Now these are, that angle measure is given in degrees, so just make sure when you're working with your calculator that you are in degree mode. So let me go ahead and pull up trusty old calculator here. There it is. Nope, it's not there yet. And there we go, magic. Okay, so what we want to do first is double check the setting on here, and that is we want to make sure we're in degrees here. So I'll go to mode, and the default's rating, which is why I always like to make sure you check just in case. So we're going to change that to degree, and then I'm going to type in 5.1 divided by, what was it, sine 36, and looks like I get roughly, now as far as like rounding, you know, I'm not super picky about that. If the directions say, you know, to round a specific way, I do want you to do it that way. So like this says nearest thousandth, 3 decimal places in case you don't remember what that means. So that means we're gonna write this as x is approximately, because we are rounding, okay, very important. Okay, approximately 8.676 would be if we truncated, but if we're going to round, we look to the next decimal, and since it's greater than 5, we're going to round up to 7. So we get about 8.677. And that, oh, and we do have some units here, it's in kilometers. Okay, so if it doesn't have units, you can just kind of leave it without the units there, but if they do give you units, let's go ahead and include them. So there we go. There's our 1A in the books. Okay, letter B. The angle we're looking at is 55, and if this is the angle in question, then this is going to be your adjacent side and your hypotenuse. So we're going to use cosine on that one. And since the work will be very similar to this, I'm just going to go ahead and copy and paste this over and just change what I need. It'll save a little bit of time on this video. So we do want to use cosine. So we're going to have cosine of 55 degrees equals the adjacent side, which is x, and over the hypotenuse, which is 100. Now it is a little bit easier to solve this when the x is in the numerator. You don't have to do 2 steps, like over here where we had to multiply by x and then divide by sine 36 to get it set up like this. This one turns out to be a little bit easier because you just have to do 1 step instead of 2. So here you would just multiply both sides by 100. So you'll end up with 100 times cosine 55. So we'll go ahead and throw that in the calculator here. What was it? 100 times the cosine of 55, not 5. And okay, so we get approximately 57.35, would be 7 if we truncate, which I'm not like I'll never mark it wrong if you truncate versus rounding, because the AP test graders will accept either one, which is kind of cool. So you don't have to worry about, oh, do I go up or down? Just, you can always truncate, but I kind of like the rounding. But either way is fine. I'm not going to mark it wrong either way. Okay, let's look at 1C. So angle in question here is the 72. So that means that 31 would be the adjacent side and x would be the opposite side. So we are going to use tangent. And again, I'm just going to copy and paste this for time purposes. And so tangent of 72 degrees is going to equal the opposite side over the adjacent side. So this is going to be more along the lines of this problem over here. Oh, let me move that calculator. My bad. Let's get that out of the way. Might have to be moving that back and forth throughout this whole video, so I apologize if I miss it. Okay, and so, yeah, don't look at these last two lines. I haven't changed those yet. So tangent of 72 is opposite over adjacent, so I need to multiply 31 on both sides. So I get 31 times the tangent of 72 degrees. And I'm going to go back to my calculator and just type that in. So as long as you know which trig function, like I think the hard part for most students in the beginning is just recognizing which trig function to use. The solving is, that shouldn't be the hard part because you're just either multiplying or dividing. Okay, so we get 95.408, and this one doesn't matter if you truncate or round, it's the same thing. And you know what, that one's yards. And let me go back and fix this one was not kilometers, this one was actually centimeters. I'm not really sure how to get a little space in there. Look for like 5 seconds and I don't see one, so I'll just keep it like that. Okay, so now these are just sort of abstract triangles, no context here, but what we do want is to know how to solve problems with a little bit of context built around them. But most of these will be solved very similar to this, like the process will be pretty much the same. You just have to identify where the triangle is, okay? And I think that's kind of the tricky part. Sometimes you'll have a picture to help you out, like this one. So let's see what's going on here. You use an extension ladder to repair a chimney that is 33 feet tall. That's labeled. The length of the extension ladder ranges in 1 foot increments. So like it could be 10 feet or 11 feet or 12 feet. From its minimum length to its maximum length. Again, like so you can't have like 12.5 feet, it sounds like it. Maybe this ladder has like notches every foot. So like you can put it at, 12 feet or 13 feet or whatever. For safety reasons, you should always use an angle of about 75.5 degrees between the ground and the ladder. Okay, that seems reasonable. So that means we're not going to be changing this angle measure down here. And so if we want this to be longer, basically what we'll have to do is kind of scoot the ladder back, okay, because the angle needs to be the same. It says the smallest extension ladder has a maximum length of 17 feet. How does the ladder safely reach the chimney? Okay, or how high does the safely reach the chimney? So basically what it's asking here is, I'm going to draw the little triangle here, okay? So we got this triangle right here. Let me make that a little cleaner. So we'll get it right. I'm trying to get this perfect because what I'm going to do is I'm going to copy and paste this diagram over. So basically we're trying to solve this triangle, yeah? And what we know about this, let me go ahead and copy and paste that, just so I can have a little bit easier time labeling it. We know that this, let's make that, let's kind of match up well, I guess it doesn't matter. That text is just too big. There we go. So how high does it reach the chimney? Okay, so we don't know that yet. That's our x, right? So that's our x. You know what? Let's make that x look a little bit more italicized here. So there we go. So there's x, and then we know that the maximum length is 17 feet. Okay, so 17 feet. How high does it reach the chimney? Okay, so the only other thing we know here is that we've got 75.5 degrees in this little angle measure right here. So now we've basically got, or you know what I'll do? I'll draw it like this, make it a little bit more obvious. Here's the 75.5. So just kind of looking back on how we solve these ones up here, we're going to do kind of the same thing. So if this is our angle in question, this would be the opposite side over the hypotenuse. We're going to use sine. So in fact, I'm just going to copy this, put this down here. Okay, so sine of 75.5 is equal to the opposite side, which is x, over the hypotenuse, which is 17. And so if we're solving for x, we need to multiply 17 on both sides. So we should get 17 times the sine of 17.5. Or no, I'm sorry, 75.5. And so we need to type that into our calculator. So let's bring that back. And there it is. Okay, so we've got 17 times the sine of 75.5. All right, there you go. So I get 16, it says round to the nearest tenth of a foot. Okay, so tenth is 1 decimal place. So just, if you, read over that and you estimate to 3 decimal places, it's not the end of the world. But it does say nearest tenth. It might matter like in Schoology when you're typing in answers, so just kind of get into the habit of checking whether or not it says how to round. So anyway, 16.4 or 16.5 would be acceptable. So, and that would be feet. Okay. Part B says you place the ladder 3 feet from the base of the chimney. Okay, how many feet long should the ladder be? So I'm going to copy this diagram because it's really the same kind of setup here, except we don't know the length of the ladder. Okay. So put the x here, and instead of this being a side that is of interest in this problem, we know down here we're going to have 3 feet. So that means we're going to use a different trig function, right? Because what we're dealing with is the adjacent and hypotenuse. So that's going to require us to use cosine. So I'm going to copy and paste this little cosine stuff just so I don't have to retype everything. We should have cosine of 75.5 equals the opposite side over the hypotenuse. So that would be 3 over x. Now this is one where x is in the denominator. So remember, we got to do like that, the old Texas two-step here. Multiply both sides by x and then divide by cosine of 75.5. So we should get 3 divided by cosine of 75.5. And I'll type that in. So 3 divided by cosine of 75.5 would be, let's find out, about 11.98. It says round to the nearest foot, so we're going to say approximately 12 feet. Part C here says, to reach the top of the chimney, your ladder needs to reach 30, you need a ladder that reaches 30 feet high. I thought it said 33 feet. Okay. Oh, to reach, yeah. So like you're standing, if you were standing at 30 feet, you could reach the top. Okay, that makes a little bit more sense. So to reach the top of the chimney, you need a ladder that needs to be at least 30 feet. How many feet long should the ladder be? But 30? Oh, no. Okay. So the ladder is not actually 30 feet. So, sometimes on these problems, you got to like read it once or twice to really make sense of it. So, yeah, when I read that, I was like, well, if it needs to be 30 feet, it needs to be 30 feet. But when it says that it reaches 30 feet high, it's actually talking about the height here. And so, it says how long should the ladder be? Here's our unknown. Let's get rid of this because we don't know what that is yet. Okay, so in this case, this would be opposite over hypotenuse, so we're going to use sine again. Sine is opposite over hypotenuse. So let's bring this down here. Sine of 75, don't even have to change that. Opposite would be 30, and hypotenuse is x. So x is in the denominator, we need to multiply it, and then divide by the sine of 75.5 degrees. So we get 30 divided by sine of 75.5 degrees. So let's go ahead and type that in. We got 30 divided by the sine of 75.5. Okay, so it says, what are we rounding to? The nearest foot. All right, so that looks like approximately 31 feet. All right, well, let's take a look at the next one. All right, so we're kind of flipping it here, and instead of solving for the side lengths, we're solving for the angle measures. So we're still going to set up our equations kind of the same way, like up here, but our unknown is going to be, let's move this over to the side. Our unknown is going to be the angle measure in here, so we'll have to use those inverse trig functions to isolate. So let's go ahead and set these up. So here is the angle in question, meaning we're dealing with opposite and adjacent, so we're going to work with tangent. So I'm going to come up here, I'm going to copy my tangent, and that way I don't have to retype everything. So here we've got tangent of x equals 6.5 over 4.2. Okay. So if we're solving for x, we need to take the inverse tangent of both sides. So we have is the inverse tangent, oops, of this little fraction right here. So again, this is just something you're going to type in the calculator, and it will be in degrees. You could give it in radians, but it's not going to give it to you in terms of pi, so let's just stick with degrees for right now. So let's see what we got here. Let me turn that back on. So the inverse tangent, you get that by doing second and then hitting tangent. See, like right above here, you got that, that blue little inverse tangent up here. To access all these blue functions, you hit the second button first. So second tangent will give you the inverse tangent, and I'm just going to type in that fraction exactly how it looks. Oop, not second. There we go. Okay. What's going on here? There we go. Okay. Always technical difficulties. I don't know. All right. Anyway, so yeah, we've got about 57 degrees. It says round to the nearest degree, no decimal places. So we'll just say 57 degrees. Nope, that doesn't like that. Here we go. All right, so let's look at the next one. We've got, looks like our angles right here, and with this being our reference, we're talking about the adjacent and hypotenuse. So we're going to use cosine on this one. So let me grab some cosine work and pull that down here. So we've got cosine of x equals the adjacent side, which would be the 1.25, over the hypotenuse. So we're going to work it out similarly to this last one. So we're going to take the inverse cosine of both sides. And our fraction is this 1.25 over 55. Throw that in there. And then let's go ahead and type it in, see what we get. Inverse cosine of 1.25. This lesson is really calculator heavy, if you haven't noticed already. So it looks like about 65 degrees, and that seems reasonable. 65 degrees. All right, I'm going to move this calculator so we can see part C here. Oh, I'm not sure what, nope. There we go. So if our angle is this x, then we're working with the opposite hypotenuse. So opposite over hypotenuse would be sine. So let's steal some sine work over here. Big fan of copy and paste, although sometimes it does bite me sometimes. Get a little copy and paste happy, and then you copy and paste the wrong thing. Just got to be careful here. So, so sine of x is the opposite side over the hypotenuse. So that means that x would be the inverse sine. If we took the inverse sine of both sides of 10 over 15, we can type that in. You can see that we're kind of doing, the same thing on a lot of these. All these problems are worked out very similarly. It's just a matter of making sure you get the right ratio down along with the correct trig function. All right, so we've got 41 about 42 degrees. Just like kind of eyeballing that, that looks like that could be right. Okay, number 4. The road at the top of the mountain. The road at the top of the mountain. I wonder which mountain we're talking about here. Sits 1,500 feet above the gas station, okay? The distance along the road from the gas station to the top of the mountain is 3,000 feet. Okay, I think before we get too much further than this, let's sketch out a little diagram here. So, you know, I'm a world-class artist here, so I'm going to give you a good drawing of a mountain. Here's my mountain. A little snow at the top. You know, here's a little mountain climber on there. Okay, I'm getting a little off track here. There's a road that goes up the mountain. Okay, so we'll just assume it's going straight up like this. And the distance from along the road from the gas station to the top of the mountain is 3,000 feet. So let's basically like sketch on the triangle what's going on here. So here's the height of the mountain. So here's our road, and here's the distance from the bottom of the road to like right here. Make a little right triangle here. So now we're going to label this. The road at the top of the mountain sits 15 feet above the gas station. So we're going to say the gas station is, I guess, here, right? But this distance, this vertical distance is 1,500. Okay, the distance along the road from the gas station to the top of the mountain is 3,000 feet. What's the angle of elevation? So this would be 3,000 feet. What is the angle of elevation from the gas station to the top of the mountain? So I guess the gas station then is like right here. Right, here's my little drawing of a gas station. Gas station. Yeah, okay. So basically, our unknown here is right here. Okay, so it's like x degrees, right? That's what we're trying to find. So let's set up our trig ratio, or let's figure out what it is first. That'd be opposite hypotenuse. That's going to be sine. So I'm going to steal my sine work from problem 3 and just change all the numbers to be what they're supposed to be. So let's see, we got opposite over hypotenuse. Oh, look, that's kind of a nice ratio there. Look at that, that's 1/2. So you can reduce it, or you can just kind of play it safe since we're putting it in the calculator anyway, and just like don't try to reduce it. You don't want to give yourself a step that you can mess up when you don't need to do that. So let's go ahead and put that in the calculator. We have inverse sine 1,500 over 3,000. There we go. And we get 30. Interesting. Exactly 30. This is the first one we've done that is like a nice clean integer like that. So we could say equals instead of approximately. I want you to think about why that might be. This is something we're going to come back to. Like, how do we know? Like, it's interesting. Like this is a pretty clean fraction too, right? 1/2. We're going to come back to that. Not today, but next time. Like that's kind of interesting. It's just noteworthy that this one is exact, where all the other ones have been, approximately. So yeah, that's something we might come back to. Let's take a look at number 5. Let me hide the calculator so we can actually read it. So suppose that theta is the measure of an acute angle of a right triangle, and sine of theta is 3/4. So let's go ahead and sketch out this right triangle. If I do this, will that, Cammy, let me do a right triangle? Nah, I don't, well, yeah, it's probably just easier to sketch it. So here's a right triangle. And you don't have to worry about drawing it to scale or anything. I'm just trying to get a feel for what these side lengths are going to be. So it says sine of theta, so let's say this is theta right here. Doesn't really matter because this is all going to be relative to that angle measure, is 3/4. So it doesn't necessarily, I'm going to just clarify something, a little sidebar here. Now, it does not mean for sure that the side lengths here are going to be 3 and 4, okay? They might be like 6 and 8, right? Because they could have reduced here. So it doesn't really matter. It's not going to affect how we work the problem. But just down the line, just keep in mind that this is a ratio. Okay, so like if your triangle had sides 6 and 8, sine of theta would still reduce to be 3 over 4. Or if it was like 9 over 12, still reduces to 3 over 4. So this doesn't say with certainty that the triangle has these side lengths, but that will not affect the ratios. They'll all still reduce to be the same. So it is safe to just sort of label it like this. And it's probably something you're not even thinking about, but I just wanted to kind of throw that out there for those of you who are kind of thinking, well, how would you tell how do you know that these are 3 and 4? We don't really know, but we know that the ratio will reduce to 3 to 4. So anyway, find the exact values of the other 5 trig functions of theta. So normally we would use Pythagorean theorem to find this missing side. So let's go ahead and do that. We've got 3 squared plus that adjacent side squared equals 4 squared. Okay, so that'd be 9. I'm just going to replace, instead of saying adjacent, I just want to kind of point that out what it is. I'll leave it. Maybe I kind of like it. Adjacent squared equals 16. So 16 minus 9 would be 7, right? So what we're going to get for that adjacent side is root 7. Okay, so go ahead and put that over here. All right, just so we've got it all labeled out. And now we can just quickly go through the ratios. Well, as quick as you can look up what the ratios are, but once you memorize them, once you remember which ratio is which, then this will go really fast because you're just basically like writing down these numbers in the correct ratio. So for example, cosine of theta is adjacent over hypotenuse, so that would be root 7 over 4. Tangent is going to be opposite over adjacent, so that would be 3 over root 7. I'll come back and rationalize at the end. I just kind of want to run through all these real quick. Secant is the reciprocal of cosine, so that would be 4 over root 7. And just flip that fraction. Again, I'll come back and rationalize. Cosecant is the reciprocal of sine, so if I ever ask like a question like that, you actually don't have to do any of this work because they already gave you sine. So I could just flip that fraction. I get 4 over 3. Cotangent is the reciprocal of tangent, so that's going to be root 7 over 3. So now, those are all your answers, and I'm actually okay with those as being your answers. Like on a, I don't have a problem with this, you just leaving it like that. Now, just because of the way we're doing assessments at Schoology, most of the time I'm probably going to have them rationalized. So, you want to be comfortable rationalizing this. So like in this, for both of these cases, we're going to multiply by root 7 over root 7 to rationalize. So that would be like 3 root 7 over 7 for that one. And then this one would be equal to 4 root 7 over 7. Either answer is fine by me, but just know that it might not both be fine by a future teacher or Schoology. You want to be comfortable doing that rationalization. So there you go. There's number 5. Oh, you know what? I never actually updated this answer up here, did I? My bad. We talked about it, but I never actually changed it. See what I was talking about being copy and paste happy? Got to be careful with that. My goodness. Yeah, I almost did not catch that. I was about to scroll down here and I saw, wait, 42? That's not right. That's 30. Okay. My bad, guys. But yeah, so that should be 30 degrees. I don't know how I didn't catch that as we were looking at it. I don't know what happened there. I haven't talked about that for, okay, you guys don't care. Let's move on. Number 6. All right, so here, what we've got here is one angle measure. It's 27 degrees. Okay, so this is the 27. Maybe it'd just be good to label it so I can get a better visual here. And the hypotenuse here is 14.3. And we're trying to find these two side lengths, which is not a big deal. We're just gonna have, this is basically like 2 problems in one. Okay, so let's start with x. If we're dealing with x, this would be adjacent over hypotenuse, and so we're gonna use cosine. If we're looking for y, that's the opposite over hypotenuse, so we'll use sine. So we're going to have to basically do two problems in one here. So I'm going to actually copy my sine and cosine work from up here. Ah, that's where the 42 came from. Yep, see what I'm talking about? Yeah, get a little copy paste happy. Not good. All right, so let's, wait a minute. Did I not copy it? I'm moving too fast here, y'all. I need to slow it down, I think. Where did I find, okay. Whew. There we go. Okay, so cosine of, let's just fix this. Cosine of 27 degrees is going to be the adjacent over hypotenuse. So that would be x over 14.3. And then just while I'm setting this up, we also have sine of 27 degrees is equal to the opposite side over the hypotenuse. So notice how these are set up basically the same. You're just like plugging in, well, you're plugging in the same numbers. It's just a different trig function because we're talking about a different side. So over here, cosine, or x will be 14.3 times cosine of 27. And we might as well just solve these at the same time since we're doing the same exact step here. And over here, x, not x, but y will be 14.3 times sine of 27. So we'll need to plug both of these into the calculator. Now this one doesn't give us any instruction as far as how to round. So since the side length that was given is to 1 decimal place, I guess we'll just go with that. You can do 3 decimals. I mean, that kind of stuff I'm not really picky about. 14.3 times the cosine of 27. Oh, you can't see my calculator. Let's bring that back. I get, okay, so we'll say that x is approximately 12.7, and we have no units here, so we're just going to leave it like that. It's almost like, maybe there could be some more information here, but okay, we'll just roll with it. 14.3 times sine of 27, so y is going to be about 6.5. Oh boy, there we go. 6.5. Okay. Looks like we only got a couple problems left here. Number 7 it says the terminal side of angle theta lies in quadrant 2 and cosine theta equals -3/5. Find the exact values of sine theta and tangent theta. I'm going to hide that just momentarily. Okay, so let's break this down. The terminal side's in quadrant 2. So, like if these are my axes, I really want to focus here on quadrant 2 here. My terminal side is somewhere over here. Okay, it says so my reference angle will be here, right? I'm going to draw my little triangle. Okay, it says cosine of theta, so we'll call this, that's our reference angle, theta prime, and of course theta's right here, but really we're going to use this triangle as our reference to calculate this. So cosine, which is adjacent over hypotenuse, is going to be -3 over 5, and we're looking for sine theta and tangent theta. So remember that sine theta is opposite over hypotenuse. So I have this unknown, the opposite, I don't know what that is yet, I'll come back to that, over hypotenuse, which is 5. Okay? And then I'm almost done. I just need to basically figure out what this side length is, right? And then tangent of theta is opposite over adjacent. So that would be, whatever that unknown is divided by -3, right? So it'll definitely be negative. So negative, I guess I can leave the -3 down there just for now. Okay, so I need to figure out what that missing side is, and then I'm basically done, right? So I would use Pythagorean theorem here, but you might recognize this is a Pythagorean triple. So I'll go ahead and solve it using the Pythagorean theorem just because, why not? So I'm just going to copy my Pythagorean theorem work down here. I have to retype all these squareds and all this stuff. So what I got here, now you could square -3, but squaring a negative is just going to be positive anyway. So I'm okay with just saying like 3 squared. If you want to, you're running into, you may run into trouble trying to do like -3. Just make sure, like putting it in the calculator, you got to make sure you have those parentheses. So just on the safe side, we'll say 3. Either way is fine because you're going to square it anyway, right? Well, now I'm going back. I'll just throw in -3. It really doesn't matter. Plus the opposite side squared equals 5 squared. Now 5 squared is 25. 3 squared is 9. Okay, so 25 minus 9 is 16, and we're going to get a whole number because of what I was saying earlier. This is a Pythagorean triple, right? It's actually a 3, 4, 5 triangle. So square root of 16 is 4. So our opposite side is going to be 4. Yeah, so that's it. I mean, we basically are done here, right? Because we figured out that this is 4. So we can go back and fill in those question marks. Sine of theta is 4/5, and tangent of theta is -4/3. So I kind of like having the negative out here, but it doesn't really matter. I think it's a cleaner way to write it. Yeah, so here are our two. Oop, that is not what I wanted. Get out of there, triangle. Okay, so yeah, there's our sine and tangent of theta. These next couple problems are going to be solved very similarly. Number 8, it says, suppose tangent of theta is -5/3 and cosine theta is positive, so we'll kind of narrow down which quadrant we're in, even though it doesn't tell us explicitly. Find secant, cosecant, and cotangent. Okay, so finding one is just as easy as finding like all the rest. It's just, once you have the triangle solved like this, it's just a matter of like picking the correct ratio. So I'm going to go ahead and sketch this out. Let's figure out what quadrant we're in. Now, tangent is negative in quadrants 2 and 4, okay? And cosine is positive in quadrants 1 and 4. So to determine which quadrant we're in, we have to satisfy both of these conditions. And so our sort of winner here is 4, because that's the only one that would satisfy both. So we know that our terminal side is in quadrant 4. It is nicer, like in problem 7, for them to just tell us, right? But sometimes you got to just use a little logical deduction here. So terminal side's in quadrant 4. That means our reference angle is going to be right here. So my triangle is going to look like this. Now this is, like I said, the reference angle. The actual angle theta is right here, but it'll have the same trig values. So we're okay to use this. All right, so we're dealing with, okay, so let's go ahead and label now. So tangent's -5/3. So let's look at this and figure out, okay, tangent's, which one is negative? And then since we're in quadrant 4, the y value should be negative, so this vertical side should be the negative one. So I'll just go ahead and sketch it out here. So this would be -5, and this would be 3. And actually, this is basically the same triangle that we had up here. It's another 3. Oh, no, it's not, because, okay, I'd take that back. Longest side. So this one's going to not be a Pythagorean triple. It almost got me there. So we do need to use Pythagorean theorem here to find the hypotenuse. So my work here is going to look slightly different. Here I've got 3 squared. I don't really need the parentheses anymore. And then plus, if you're going to throw in a negative, make sure the parentheses are in there, although you could just use 5. It's just as good. Equals the hypotenuse squared. So that would be 9 plus 25 equals our hypotenuse squared. So 9 plus 25. Oh, wait a minute. 36? Is this a Pythagorean triple? Hold on. Oh, no, 34. I was like, I don't think that's a Pythagorean triple. Yeah, I need to work on that arithmetic. Okay, so 34 is going to be our hypotenuse squared. So our hypotenuse is going to have a length of root 34. Does that have any perfect square factors? I don't think so, because the only, yeah, it's 7, well, yeah, 17 times 2, and neither one of those are perfect squares. So it's just going to be root 34. Oops. Okay, so go ahead and let's copy that, and we'll label this side over here. This is going to be root 34. So now we're going to write all these. So we'll say secant of theta, which is the reciprocal of cosine. Okay, so cosine is adjacent over hypotenuse, so this would be hypotenuse why isn't it copying that 34 for me? Come on. Copy. Paste. There we go. So it's going to be hypotenuse over adjacent. Cosecant is the reciprocal of sine. Sine's opposite over hypotenuse. So this would be hypotenuse over the opposite. So that would be the root 34 divided by the opposite side, which is -5. So just to kind of clean up the fraction, I like I said before, I like having the negative in the front. Doesn't really matter. That's just sort of personal preference. I'm not going to mark off points if you do that or anything. If you leave it the way it was, I just kind of like how the number looks a little better. And then finally, cotangent, which we actually don't have to do any work for because cotangent is the reciprocal of tangent, and tangent was given, right? Tangent was -5/3. So cotangent is going to be -3/5. There you go. So there's all those three trig functions. Number 9, same deal here, y'all. Basically, we're going to fill out this triangle, and then we'll just start listing out all, it looks like we need to find all 6 trigonometric functions. So we're going to have our hands full here with trig functions. Okay, so let's go ahead and use our Pythagorean theorem. Now here, we're dealing with the adjacent side. So I'm going to go back and steal this adjacent one. So I can just sort of stay consistent here. Okay, so we've got 1 squared plus the adjacent squared equals 3 squared. 1 squared is obviously 1, and 3 squared is 9. 9 minus 1 is 8. And so we get the square root of 8, which we can reduce, but y'all, let's just leave it as root 8. I mean, well, okay, if you were to simplify it, think about what that would be. Root 8 has a perfect square. I know I keep going back and forth on that. I'm not going to be sad if you leave it as root 8. I will shed no tears. I'll mark off no points. But if you were to simplify it, and maybe our ratios will work out a little nicer being simplified like that, I would get, come on. So 8 is 4 times 2, and the square root of 4 is 2, so we get 2 root 2. All right, so let's go ahead and just list all the 6 trig functions. I think we're just going to just type them out. Sine of theta come on, theta. There we go. Sine of theta is going to be opposite over hypotenuse. It's going to be 1/3. I didn't need to do any work for that one. Cosine of theta is adjacent over hypotenuse, so that would be the 2 root 2. Actually, that might be worth copying, so I have to type that in over and over again. 2 root 2 over 3. Now, if you just leave that as root 8/3, I'm totally fine with that. Tangent of theta is opposite over adjacent. Okay, I just kind of ruined that. There we go. So opposite would be 1, and adjacent is 2 root 2. Now I'll come back and rationalize. I'm not too concerned about that at the moment. If you just leave it as 1/√8, I don't have any problem with that either. So let's go through the other 6 trig, or the other 3 trig functions, the 3 reciprocal trig functions. So what I'm going to do is just highlight this, copy and paste it. I'm going to switch all these to their reciprocals and just kind of do them one at a time. The reciprocal of sine is cosecant. So this would be 3/1, which is just 3. The reciprocal of cosine is secant. So this would be 3 over 2 root 2. And again, I'll come back and do the rationalizing if I need to. And then the reciprocal of tangent is cotangent, not cat, cot. cotangent. And so that would be root 2 over 2 over 1. So that's just root 2 over 2. So it looks like there's just 2 here that need to be rationalized. That can be rationalized, I should say. So if you were to rationalize this, you would get 3 root 2 over 2 times 2 would be 4. Yeah. And then for this one, if I multiply this by root 2 over root 2, I would get root 2 over 2 times 2 is 4. So root 2 over 4. Either answer is good. So there you go. There's all 6 trig functions. We got sine, cosine, tangent. Oh, that's weird. Sine, cosine, and tangent. And then the other 3 reciprocal functions, cosecant, secant, and cotangent. We got all 6 of them. We got one last problem here. The terminal side of angle theta passes through the point -7, -2. Determine the value of cosine theta. So let's go ahead and sketch where that is. Now the quadrant where both x and y are negative is quadrant 3. Let's stay consistent with the other one. So do my axes in blue just so they don't kind of get caught up in the rest of the diagram. All right, so -7, -2 is going to be like, I don't know, here. It doesn't really matter if it's, we're not drawing a scale here. So there's my terminal side, meaning like theta is like right here. But my reference angle is going to be this one right here. So the triangle that I'll need is this one. Okay. And since that's -7, -2, I'm going to label these sides as -7, -2, and what I need is cosine theta. So if this is theta, cosine would be the adjacent side over the hypotenuse. So we know that cosine, here, we'll just do this. We know that cosine of theta is going to be the adjacent, which is the -7, over the hypotenuse, which we do not know yet. So I'm just going to put a little temporary question mark there. Once we find that, we're done. So let's go back up to where I did that before, the Pythagorean theorem, and I'm looking for the hypotenuse. So yeah, I'll steal this work over here. Okay, so here we've got -7. Y'all, I know I've been throwing in the negatives, but you really don't need to. Like, to just keep it simple, just do like 2 squared plus 7 squared. Right? Remember, when you square negative, it's going to be positive anyway. So just save yourself a little bit of work here and just do 2 and 7. So 2 squared is 4, 7 squared is 49. 4 plus 49 is 54. Oh, no, 53. And then so, yeah, we got the square root of 53. And that's going to be our denominator. So that would be an acceptable answer. I'm totally fine with that. If you choose to rationalize, just so you know what the right answer should be. If you rationalize, you're going to get -7 root 53 over 53. I'm going to pull that negative out here. All right, well, that was a lot of problems, yeah? As always, if you guys have any questions, let me know, and I will try to help you out. But other than that, y'all have a great day, and I'll see you guys next time.